So I welcome you all to this class, and today we are going to see an animation and understand how the position, velocity and acceleration have the effect in our real life. In the last video, that acceleration is something which is changing with velocity, and today, before we move further for graphs, let us first understand those graphs here only with these illustrations. So as you can see here, one man is standing there at the center position that is written 0 meters. So if I start this pointer here, let us see what we observe. As you can see, he is standing at one position only, 0 meters, and time is increasing here. That is 7 seconds, now it is 8 seconds. So basically he is not moving. So what we say is that line on this blue axis, velocity is 0, acceleration is 0 is okay, but position is what? 0, and he is at rest. So he is considered to be at rest position right now. Now there may be some other cases also. For example, if we change the position of that man to 5 meters, so I'm placing him at 5 meters now. So he is now standing at 5.24 meters and time again started. Time is increasing, but his position is not changing. This is also a case where we can say that yes, he is at rest, but now the graph is slightly bit higher because the position is changed to 5 meters. Okay, now coming back to the second case. As we have seen that an object can be at rest, it can be at 0 meters, it can be at 5 meters, but now we have to see that what is the effect of velocity and how this velocity will change. So I've placed the man at minus 10. Minus 10 means because we are moving in the negative direction, we are moving behind the axis, that is minus 10 meters. So total basically it is 20 meters. From minus 10 to 0 it is 10, and from 0 to 10 it is 20 meters. So distance is 20, but displacement will be 0 somewhat else. Now I'm setting the velocity at 1 meter per second. So now the velocity is 1 meter per second. Let us see what happens. He start moving. As he go on further, this position graph is increasing because his position is increasing. He reaches to a 0 point, he crosses a 0 point, and position is increasing. While the velocity is not increasing. Velocity is how much? 1 meter per second. So from this example we can see that if velocity is 1 meter per second, that is constant velocity, then position will change. So after 21.3 seconds, he must have covered some 20 meters. Okay, coming back. Again, if we change the velocity to some 2 meter per second, and let us change the position also. So now we are having the position at minus 10 meters and velocity is 2 meter per second. So let us see what happens. He is moving little bit fast because velocity is increased now, and position is also increased. Now he has covered in 9.3 seconds, almost we can say 18 meters. Why 18 meters? Because this is starting from 10, minus 10. So minus 10 to 0. So it is basically 10 meters, 10 to 8 plus. So that is 18 meters. He has covered in 9.3 seconds, which is not factually correct, but yes, it is somewhat correct. Now let us see the effect. Acceleration is still 0. You can see here acceleration is 0. Velocity is constant. Acceleration is defined as rate of change of velocity. So now you see here I have placed the man at minus 10 meters. Velocity I am putting is 0, and acceleration I'm keeping as 1 meter per second square. That for each second velocity will change 1 meter per second. So let us now play. So he start moving. In the starting he is slow, but now he is very fast, and as you see his velocity is very much fast. So you see the graphs. Position is increasing very fast. Why? Because velocity is changing. Each second velocity is changing by 1 meter per second. Acceleration was 1 meter per second square. So basically in 6.3 seconds his velocity is now 6.25 meter per second. So this, at this time, the velocity acquired is known as final velocity, while the initial velocity was 0, and now position is almost around, we can say, 19 meters. So again, if we change the acceleration, again it will be like 2 meter per second square. We are keeping the acceleration. Velocity is again 0 and position is minus 10. Again we start. So in starting, you see, in starting the velocity was quite slow, but now it is going on increasing. So this is how we can say that velocity changes and there is acceleration. If we put negative acceleration, -1, so let us see what happens. So he will be coming back. Minus means retardation. So this is moving in negative direction, and hence this is the case of retardation. So now I hope that all these are clear. So basically we can point out some points. So our first point is, if position is not changing, then object will be at rest, which is quite true. If object is at rest, velocity is 0, acceleration is also 0. Second point, we can say velocity is constant, then object is in motion. If velocity is constant, then acceleration will be 0, but object will not be at fixed position. Third is, if velocity changes, acceleration is not going to be 0, and hence the object will be in motion. So these are the three important points which you have to be keeping in mind while solving the numericals also. Okay, thank you.